All right, Physics 30 is the last one I have time for today on refraction. Snell's law, critical angle. We're looking at page 82, question 10, the old equilateral prism problem. All right, it says a horizontal ray of light enters a piece of glass, n equals 1.52, shaped as an equilateral triangle. What's the angle of refraction when it leaves the glass on the other side? Well, an equilateral triangle has 60-degree angles, okay? Okay, so that's a nice place to start by putting in some angle measurements. Now what I want to do here is I want to realize it's a horizontal ray, and so the bottom of this is horizontal. And so what we have here is essentially two parallel lines. So what I'll do is I'll draw my normal to the surface right where it intersects there. All right, so there's my normal line. Now if this, of course, is 60, then that means that this right here would have to be 60 degrees as well. Now that leaves this obviously being 30 degrees. So theta 1 is 30 degrees. Now I like 1s, 2s, 3s, 4s, and that kind of thing in this type of problem because it just kind of goes from 1 to 2 to 3 and it kind of follows a nice order. Now we know that it's going into this glass, and the glass has an index of refraction that is higher than air, so it's going to in fact refract towards the normal. And so it'll do something like this. Okay, I won't make it too dramatic there, but something like that. Okay. This will be my theta 2. Now the goal of this here, since I want to know the angle of refraction when it leaves the glass on the other side, I need to find theta 2 as a good starting point. Then what I'll do is I'll start moving around this equilateral triangle. I might call this one some variable. I might call it something like, how about gamma? Okay. Then when it comes over here, I'm going to want one more variable. How about beta? Okay. So I'll just use some variables there to kind of set things up. Let's find theta 2. So to set that up, it looks like this. I have sine theta 2 over sine theta 1 equals n1 over n2. So sine theta 2 over sine 30 degrees is equal to n1. Well, where was it? It was in air, over 1.52. All right, let's figure out what theta 2 is. So do make sure you try this. Okay. 19.2 degrees, kind of what I thought. It'd be something smaller, obviously, than 30. 19.2049 degrees. Okay, now what I want to do is I want to move around here and figure out what gamma is. Well, gamma obviously is going to be 90 degrees. Take away 19.2049. So let's do that. 70.7951. Now we know that, of course, in this triangle right here, we have to have an angle sum of 180 degrees. So I can figure out what beta is now by taking 180 degrees, subtracting away the 60 from the top there, and the 70.7951. Okay. 49.2049. Okay, now what I'll do here is, I know I kind of wrote in the space and where I wanted to get this problem wrapped up, but that's okay. I won't put too much more on there. So here's going to be now the boundary between the glass and the air once again. This is what I'd call theta 3. And then theta 4. Now it's going to refract away from the normal, and so it'll probably kind of move outwards like this. Okay? I'll try and make it a little bit dramatic and just with the space I have here. Oops, sorry. Now this will be what I call theta 4. Okay? Still show the direction it's moving, kind of get that idea. All right, let's find what theta 3 is then. Theta 3 will be the complement to beta, which would be 90 degrees, take away 49.2049. Notice I'm just storing all this information in my calculator, so it's easy just to keep moving along. Okay, 40.7951. Now we can go ahead and find theta 4 in the same way we did here, right? If you notice what we did here, we have the same kind of thing happening just at the end here. And so you know kind of what you need to do here. It's pretty obvious to me, but maybe not to you. The sine 30 here now just becomes the sine 40.7951. These two get flipped because really you want a larger value. So when you take the arc sine, it's a bigger angle. And so taking 1.52 divided by 1 rather than this will achieve it. But in case you're not seeing that, let's just set it up the way it is. Okay, so sine theta 4 over sine theta 3 equals n3 over n4. So let's put in my information. So sine theta 4, that's what I need to find. Sine theta 3 is going to be sine 40.7951. And over here I have n3. Now n3 is the 1.52, and then 4 is 1. Notice I already talked about that. Let's go ahead and figure out what theta 4 is. All right, I got 83.3 degrees. Okay. Wonderful, thank you very much.